Hi, my name is Abner Lusong. I'm studying for a Master of Science in Computer Science in East Texas A&M University, and I will be presenting the CKY Parsing Project. First, first part, I'll be showing you the parser code and executing the 20 valid sentences and 3 invalid sentences. And after that, I'll be showing the document that outlines the details for the project requirements, like the CFG, the conversion, the snapshots, and other else. After that, I'll be going back to the code, showing how each code process each step. Okay, now let's do the first part. So my code has multiple functions, and right here in line 347, I need to have the CFG, and the CFG will be the one converted to a CNF. And when then the CNF is converted, I will pass this to validate my sentences. So first is, so I'll be showing this in the later part of my presentation, but right now I'm focusing on validating these sentences. First part, I have here the list of sentences I want to validate if it's okay or not okay. Save. So it in the terminal, it says yes. So I just copy this and paste it here. And I will do the same thing for the next steps. Locate books by title. Next, run the validation. Another yes. Next sentence. Retrieve books by genre. Another yes. So what my program does, it always looks if the last one in the cell in the in the grid has an S, which is the starting of the sentence. So I will continue for the next. Search books by category. So yes. And yes. Next is retrieve the shortest book. It's a yes. Next is search recently returned books. It's a yes. It's a yes. Retrieve books with multiple authors. Search books with illustrations included. Search books with damaged pages. Locate newly catalog library books. Locate books in science section. Let me just locate books written in Spanish. Retrieve books sorted by popularity. Retrieve books currently unreserved. Retrieve books stored in archive. And this is my longest sentence. Search books based on subject keywords. Next three will be the invalid sentences. Books by author find. It's a no. Locate in Spanish books written. Also a no. This is my last invalid sentence. Sorted by popularity. Retrieve books. It's also a no. Oh wait, I didn't save and run. It's a no. And that's all for the running the parser code for the 20 valid sentences and running the 3 invalid sentences. So we move on to the next part of the presentation, which is the presentation of the document. So this is the front page of the document. The title will be the online library book search. And the table of contents, it contains the description, context-free grammar, 20 valid sentences, and 3 invalid sentences, the conversion of the context-free grammar to Chomsky normal form, and the CKY tables when we're trying to validate the sentences, a copy of the parser code, and execution snapshot of the parsing of each sentence. So the online library book search is a web-based tool that processes book search queries and returns relevant status, which is what we did, if it's okay or valid or invalid, okay or not okay. The tool focuses on the key book attributes such as the author, title, genre, and category. It can also interpret descriptive search terms such as newest, longest, or shortest to refine the results. In addition, users may specify the type of material they are searching for, such as audio, books, or science books. The system further supports time-related descriptors like recently, newly, and currently, allowing for more precise and context-aware searches. We move on to the context-free grammar. So these are my non-terminals. S starts the start of the sentence. BP verb phrase. NP noun phrase. Participle. PN is preposition noun. S, verb, NP, verb, verb modifier, noun, verb, BP, verb modifier, NP, BP, verb, noun, modifier, adverb participle, noun phrase, that adjective, noun, and the preposition proper noun. Lexicon contains most of the terminals, which are Spanish books, so on and so forth. And the left side is the non-terminals to get to the non-terminals. The left side is the non-terminals used to get to the terminals. And these are the 20 valid sentences and 3 invalid sentences that we have executed inside the parser code. The process is, first we killed the conversion is we to convert the CFG to a CNF. First we kill the null productions, but for our case of the context free grammar that we use, we did not introduce a null production, so we're skipping this part. Also, in this part is kill unit productions, so we identified which are the unit productions. So here we have the SBP, and we included what will be the one that will create update this. So I added the BP because BP will be the one on top of the S. Such an example as BP is replaced by verb modifier NP, like here. S. So additional productions were added because we killed the unit production, which is the SBP. And the rest we keep. And apply theorem 25, we skip this part because there's no changes required. We don't see any non-terminals inside the in the long right-hand side. And next is applying theorem 26. We did find more than two non-terminals, so we introduced new productions x1, x2, x3, and x4. And this is the final form after the transformation. Next, we go to the valid sentences. This is the find books by author. I think we will not go through to each table, maybe only for the first two. So find, we get the verb. Next, books, we get the noun. Then we get the combination, which is the SBP. Next is the preposition. Next, we next the combination of non-preposition, there's not available. Next is the combination for 03, which is 0113 0223. There's nothing found. Next is the 34, which is a noun. First is the combination of 23 and 34, which is a preposition noun, PN. Next is for the 14, we look at the combination 1 2 2 4 1 3 3 4. No combinations found. For the next last is the 04. We look for combinations 01 1 4. So it's 01 1 4. So it's an X, so nothing. Next is 02 2 4 02 2 4. We have BP and PN will produce or its equivalent S is equal to BPPN. It's S. And last is 03 and noun. So it's an X. So it's an S, so it's accepted. So yeah, let's move all to all this. And this is the invalid sentences. Sample is books by author find. 01 is noun, 12 is a preposition. We check the combination. There's no combination between noun and preposition. We go to the next. 2 3 is noun. And we get the combination of 1 2 and 2 3, which is preposition noun, PN. Next is 03. 03, we get the combination of 0113, 0113. which is not available. X. Next is 02 and 02 and 23, also X, not available. Next is the 3-4, it's a verb. Find verb. 2-4, we get the combination of noun and verb, not available. 1-4, we get the combination of 1-2, preposition X, so it's an X. PN and verb, also not available, we return an X. Last part is we get the combination of 0-1 and 1-4, it's an X. 0-2 and 2-4 is also an X, and 0-3 and 3-4 is an X. So it returns an X, so this sentence will not belong to the grammar. So yeah, so parser code, maybe it's better if I go back to I the IDE to get to show the code. Yeah. So first is I introduce a class object which is the grammar that will contains all the terminals and non-terminals in the starter productions. Then the main functions that it's working on is the get CFG, validate sentences, apply tier 25, kill unit, and kill null productions. So all of these are applied under the 2CNF. So I would use them to have a series of transformation. First, I pass the grammar to kill null productions. Then I pass the result to the kill unit productions, pass the result of the applied tier in 25 plus the result of applied tier in 26. And that's it. And after I got the grammar, so this grammar will be as in CNF form. Then that's the time I validate the sentences. So this one, I iterate through all the columns, or I create a grid based on the columns and rows and check all of the combinations from there. And I check on the first row, last column, if it contains the start, which is the S, or if it's not S, it could be anything, but this one, in this case, it's an S. So if it's an S, it returns yes. If not, it returns no. So that's it. That's the end of my presentation. Thank you very much.